Okay, after marking your lab report, I realized that some of you are making some very basic mistake, and because of that, I would like the whole class to do their correction. You can do your correction directly on your lab report with a different color ink, green, blue, black, whatever, as long as it is a different color. Whereas some of you, I have indicated on your worksheet that I want you to redo your graph, and that's because your graph contains too many mistakes and you cannot afford to learn slowly because you only have like 6 lab sessions per year. Okay, so in this video I will be going through with you some of your common mistakes, and I hope you can perfect your lab report because it is really easy to score. Okay, so let's begin. How do I go to presentation mode? Okay, here. Okay, for your table, most of you are doing fine. You are able to give me the correct precision, and I think that's because I have gone through this with you. There's one exception. Okay, for your calculation, that means this part, the process data, please remember to keep this in 3SF. Okay, when I say 3SF, the 0 in front does not count towards these significant figures. Okay, please go and revise on your mathematics for that. As to commenting on the relationship, like I say in class, there are 3 relationships: linear, directly proportional, and non-linear. So the common mistake is that some of you have indicated that they are directly proportional. Now, in order to do that, you need to give me proof that your graph passed through 0, 0. Meaning that you need to prove to me that when you use the equation y equals to mx plus c, the c is 0. And that when you sub in 0, 0, it actually makes sense. Okay? Okay, the next thing is about your graph. This one I'm quite disappointed because you are given the checklist to confirm that your graph has all the components of a perfect graph. So let's begin. Okay. The axis, most of you are following my instruction to draw the axis line on the edge of the graph grid. Okay, as for your graph title, some of you forgot to indicate the unit. Okay, and this is very silly because this is 1 mark, and if you don't indicate the unit, 1 mark gone, so it's wasted. Same thing for your axis label here and here, it should always have unit. I'm happy that most of you understand that you should start, okay, at your lowest value so that you don't waste space in the graph paper. Okay, but I'm pretty disappointed with the guys because you have forgotten to indicate all this. Okay, I have already told you every 20 square, this is 20 square. Every 20 square, you need to give me a marking. Did I do wrong? This is... Oh, sorry, this is 10 tiny square. Okay, so it's my fault. Sorry. Okay, so every 10 tiny square, you need to give me a scale marking. Okay, similarly for the side, I know there's a typo here. I have not changed it yet. Okay, like I say, I intend this typo there to check who is alert. Okay, so the second error is that when you are doing your best fit line, okay, some of you will have the instance whereby the data point align nicely on your best fit line, and it is very tempting for you to choose this point as your gradient for your gradient calculation. This is not allowed. You cannot, if what you have done is this, let me change the color. So what happens is that, oh, you got this point is very near. Okay, let's use this point as my gradient calculation. So I got 101.34. You notice that when I choose this, it is the same as this. This is considered using experimental data. Okay, if you do this, I will have actually marked you wrong. Okay, you cannot do that. You have to go and pick either this point here, and when you pick a point, can you please cross it or you dot it and then label the point. Okay, I want to see the coordinate that you use. And similarly, you need to choose a lower limit, so you can choose anywhere that is convenient for you to read. So you can actually choose this. After you choose this point, remember to form this. This is what we call a gradient triangle. You need to have this. Okay, and then you can use this value here and this value here for your subsequent calculation. Okay, so that is for your graph. So I'm going to skip this part because we have gone through this in class. Okay, down here I see that some of you either leave it blank or you have just tick it. Okay, I don't want that. I want you to look at your graph and check. And if you find that something is missing, add to it. Okay, you should rectify the error before you submit your graph to me. Okay, so this is something that you should take note. Okay, for this, I noticed that some of you think that G stands for gradient. Okay, some of you think like that. This is wrong. Okay, this is not what I meant. This is wrong. Okay, G is actually a universal symbol that indicate that it is the gravitational strength. Okay, you have not been taught this, so I'm going to kind of forgive you, but G is not gradient. The universal symbol for gradient is actually M. Okay, as in y equals to mx plus c. You learned that in mathematics. This guy represents gradient. So what you are trying to do is that the teacher has given you a physics equation and you have drawn a graph of t squared against L. Okay, so what you need to do is that you need to rearrange your equation such that this guy here is the y-axis and this guy here is your x-axis. And you can actually see that this part will fit to your gradient because a straight line's equation is given by y equals to mx plus c, right? So you can see that, you know, it matches. Yeah, so it matches. It's fine. Then some of you may be asking me, teacher, but my c is not 0. Does it mean that you are wrong? It's fine because experiment has random error. But your gradient should match with my value. Okay, so it doesn't matter whether your c is 0 or c is other value. As long as you have completed your experiment correctly, your gradient value will be very similar to the teacher's value. Okay, so down here what you are going to conclude is that the gradient of your graph is actually representing this chunk here, 4 pi squared over g. Okay, where g is the gravitational strength, which is 10. Okay, our Earth gravitational strength is 10. Okay, for secondary school it's 10. Okay, when you go to JC you learn that it is actually 9.81. Yeah. Okay, precaution, this part here you need to go and look at the Google Drive and go and write down the suggested answer. Okay, the other question that most of you got it wrong is this one here. When they are asked to find what is the period, when you ask to find the length of the pendulum when the period is 2 seconds. Most of you, what you all did is that you all go to your graph. Okay, and let's say this is your graph. You go and look at period, there is 2. Oh, period is 2 is somewhere around here. Let's say I have 2 here. Then you read your graph. This is wrong because your graph is t squared. Okay, so when they ask you, I want a period of 2, period is actually given by t. Then you may ask me, teacher, how I know period is t? Read your lab report. I have actually written there in the instruction. Period is given by the letter capital T. So if you want to find what is the length of your pendulum when your t is 2, then t is 2, right? But your graph is t squared. So meaning that when t is 2, t squared is 4. You need to go and read off from 4 what is the L. Then you may have said, teacher, but my graph never reached 4. Then how must I redo my graph? No need. Because your graph here is given by the formula t squared equals to ml plus c. What is t squared? How you know? Because as long as it is a straight line, you follow this equation, right? Y equals to mx plus c. But now because your y-axis is called t squared, so that's why I changed the y to become t squared. Then what happened to my x? Your x-axis is now called L. So that's why your x is now changed into L. So you follow this equation. So t squared equals to ml plus c. Then you may ask me, teacher, but what is m? M you have found, right? You have calculated what is your gradient here. Correct or not? So m will be some gradient. So in my case, it will be this, right? 58 minus, no, this is 97. 97 minus 58 L plus C T square. So this is your gradient. Then what is my C? Well, you can substitute your value inside, right? So once you find your gradient, you substitute this inside lah. T square is 1.4 equals to the whole chunk. L is 97 plus C. So you can work out what is your C, right? Once you work out what is your C value, then what do? Once you work in your C value, let's say this C value is 0.5. Let's say, okay, let's say it's 0.5. Then what you do? You know your gradient, right? And you want to find what is L when T square is 4. So what you do? You substitute. Let me change the color. You can then substitute your T square to be 4 equals to the gradient. Okay, you go and calculate what is the gradient. You want to find L. So this L here, you do not know. So you put L plus C. C you have found out earlier that it is 0.5. So you know this, you know the gradient, you know the C, you just need to find this unknown. So this L, you can actually calculate, and once you have calculated it out, you can then answer this equation. Yeah? So this is how you answer this question. So this is it. Okay, down here I'm quite happy. This one, okay, don't go and tell me start point, end point, whatever point. It's called a reference. You need to learn this word. This one, most of you are able to. Common mistake for this part here is that you all didn't indicate the unit. Okay, 0.1 watt, 0.01 watt. Okay, you need to tell me the unit. Then possible source of error, I have mentioned already. All these things, zero error, parallax error, human error, they are not source of error. Once you give me that, is 0. Okay, and how do you write a source of error? Source of error, there's a specific way for you to write. And there are 3 components. First, you describe what happened, what is the error. Then you relate, why is this an error to my experiment? And finally, and most importantly, is that you need to identify the parameter here. Okay, which one is affecting the experiment? Okay, so there are actually two other suggested answers for you. This one, you describe that you cannot identify the highest point accurately, and then you relate why is the highest point an error to the experiment. So that is because you are using the highest point to count your oscillation, right? So because of that, you are unable to count. So finally, identify which parameter is being affected. Okay, same thing for the third source of error. So this word I think you have not learned. It's called elasticity. So some of you mentioned that because of the different in tension and the tensions are different, and so the length is affected, right? The scientific term for this is the string is elastic. Okay, because it's elastic, the length will change. Okay, so learn that word. So I hope this is clear. If you still have questions, like for example, you are still not very sure how do I answer, if you are still not very sure how I answer this question, WhatsApp me, make an appointment, then I will go through in greater detail with you. Okay? So please remember, do your correction. For those who need to redo your graph and check. Okay, if this time round your graph is still wrong, I will make you redo 5 times. Okay, you need to learn the skills. Okay, so thank you very much, and I'm looking forward to mark your correction. Bye bye.